Back, third grade. We are working again on some polygons. So if you haven't, go ahead and cut out lesson 5, the template for lesson 5. If you are unable to print, no worries, you can follow along with me, but I think it would be beneficial if you are able to print to get these printed and cut out so that you can see them and touch them and not just see what I have. Okay, so we are on to lesson 5. So if you would, please read the bottom with me. There we go. It says compare and classify other polygons. So if you'll remember our last lesson, in lesson 4, we were talking about what kind of polygons? Say it out loud. Yes, quadrilaterals. Today, we're going to be talking about other polygons. And we're going to be figuring out how many sides they have, etc. Okay, so it says, number 1 says, please read with me, cut out all the polygons M through X in the template. Then use the polygons to complete the following chart. So, a list of letters for each group, and then we're going to do one sketch. So the first attribute, which is like a quality of the shape, it says all sides are equal. So here we have a mess. Just a mess of shapes. So we need to find all the ones that have equal side lengths. Okay, that's easy enough. Some of these, just by looking at them, we'll be able to tell that they're not equal. For example, this one, right? If we look at V, I know that this side is super short and this side is pretty long. Are those going to have equal sides? All sides equal? No, bye-bye. How about this one? Short, long, no, bye-bye. How about this one? This one's a wackadoodle. This one's long, that one's no, goodbye. How about this? Maybe. I'm going to set that guy aside. How about this? P. Could be. Let's set that aside. How about, okay. I would say no, right? This one's real long. Look how tiny this one is. No, those are not equal. Goodbye. How about this one? M. It could be. We'll save it for later. How about U? Maybe. How about Q? No. This one's this long. This one's longer. No. S? Maybe. R? No, right? Because the bottom is this size. The top is not as big. And this one, I would also say no. This one's going to be shorter than like this side. Okay. Now, if you have a straight edge or a piece of paper, that's what you're going to use to see if the sides are equal. Okay. So much as we did, like we did yesterday, just get a piece of paper. Could you use a ruler for this? Absolutely. I don't have a ruler, so this is what I'm going to do. Another way to measure, right? So I'm just going to follow along. I'm going to kind of trace the side. And when you're cutting, I should probably tell you this before, huh? But when you're cutting, if you can leave the black on the outside, I think that would really help you be able to see the sides better. Okay, so I traced one side. Now I want to see if all the other sides are equal. That one is. That one is. That one is. That one is. I'm assuming. And that one is. Okay, we have our first one. So our first polygon with all sides equal is U. How about S? Looks like a square to me, but let's see. Let's use our little straight edge and trace the same length of one side. Ooh, there we go. And then let's go turn it and see if that side is the same. It is. How about this side? It is. How about this side? It is. So we have our second one. S has all sides equal. Let's see if I can. I'm sorry we're a little bit blurry today. Just bear with me. Okay, how about P? Let's do the same thing with P. If we do one side, about the length of the one side. This P has a lot of sides, doesn't it? That looks like to be the same length, same length, same length, same length. Boop, 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 boop. Yep, okay. USP, all the same length sides, every side equal. How about W, I wonder? Let's try it. The long line for W. That side is exactly the same. Oh, and that side is exactly the same. I almost thought that those were going to be equal, but this one also has all sides are equal. And our last one is M. Let's see. I have a good feeling about this. Yes. 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 Equal. 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 Woo. Okay. We have 5 shapes that are, let me turn on this light, see if that helps things. Maybe a little bit. Okay. We have 5 shapes with all sides equal. Now I'd like you to choose one and sketch it out over here. Anyone you'd like. I think I'm going to choose you because it's kind of fun, but also a little bit easy. Awesome. Okay. All sides are not equal. Well, we can count all of these out, right? That we just went through and classified because all of those are equal. So all sides are not equal. So that means not even 2 sides are the same, right? So has some sides, all sides are different, in other words. Okay, so looking at this one, I can tell right away that this side and this side are going to be the same length. This side and this side are going to be the same length. So that does not qualify. This one, however, let's see. These long sides might be the same, but I don't know. Let's trace the long side of Q and compare it to, or one of the longer sides, compare it to the other side. And see if they're the same. Oh, it isn't. Okay, and we know that the short side obviously is not going to be equal. So Q is the first one with 3 different length sides. How about V? How are we going to classify this one? Do any of these look the same to you? Maybe this one and this one could be the same? Is that what you're thinking? This one looks, obviously this one's shorter. This one looks shorter also. But if anything, maybe those two and maybe that one. Let's measure. This and compare it with this. Oh, those are the same. Okay, doesn't qualify. We already know that this is equal to this is equal to this. Sorry, you're not in the running. How about this wackadoodle one? I'm talking about, oh, look at this wackadoodle. What do you think? Do you think any of these sides will be equal? Just by looking? I don't think so. Like maybe this one and this one, or this one? Let's just trace one of those sides and see, just so we can do our due diligence here. I'm going to trace one side here. I'm going to compare it to this side. Is it the same length? No, this one's longer. How about this side? No, that one's shorter. Okay, we have our second qualifier in O. R, we already know, right? That that this side and this side are the same. If we wanted to check our work, we could, and I'm going to just to prove it. Yeah, see those sides are the same. So R is not qualified in our not sides, varying different sides. Okay, you know what I mean. How about this one? It doesn't look like any of the sides would be equal, but I feel as though we should check just to be sure. Which sides do you think might be equal in length? Maybe like this bottom one and this one, or this one? Maybe this little one and that one? Okay, well, let's try. We'll just see. Maybe the top and the bottom are equal. So I'm going to trace this top line, and I'm going to compare it with the bottom. And the bottom is a little bit larger, so that doesn't check out. How about this one? This is, oh, those sides are exactly equal. Well, what do you know? Okay, sorry, X, you do not qualify. So we only have two. We only have two that fit those attributes, O and Q, that have three different, or have all different sides. Sides. Okay, go ahead and sketch one polygon from, you have two choices. So if you want to be bold and try to trace or sketch this one, you may. I am not going to be so bold. I'm just going to trace this little triangle. Not trace, but sketch. Hypotenuse. There we go. Okay, let's move on. Our next attribute is at least one right angle. Remember, a right angle is where perpendicular lines meet. Get my little, what's this thing called? Whiteboard out, right? So perpendicular is when a line is down and it cuts the other line right through it, like so. That's perpendicular, and a perpendicular line makes a right angle. Right angle, right angle, right? So that's what makes a right angle. You can also find out if it's a right angle by using the corner of your straight edge or a piece of paper, right? So let's go through our shapes and find which shapes have at least one right angle. Let's start with Q. We just had it. What do you think? Look at that. Q has a right angle. Q. How about O? Right here? Nope. How about this little? Nope. Sorry, O. How about these ones? All of these ones that had equal sides. It's kind of the batch I'm working with. How about S? I bet you can tell by looking that this has actually not one, not two, not even three, but four right angles. So S is definitely part of the team, part of the right angle team. How about this one? I don't think so. No. Nope. No W. Oh, sorry. Do not qualify. Okay. How about M? No. This is not going to have any of those right angles. How about U? Again, it's similar to M. It doesn't have any right angles. We're moving on from that. How about X? Can you find where one might be? What about this one? Is this a right angle? Oh, you know what? This one's really close and it might trick you, but it's not a right angle. That does not fit perfectly in there. What about this though? That looks pretty right. It does. That is a perfect little right angle right there. Well, wouldn't you know it? Has at least one. Okay. R, can you tell by looking? Hopefully at this point you're getting pretty good at this and you can tell just by looking that this is not going to have any right angles, right? If that's not, that's not, and that's not. Nope, moving on. How about V? The only one that I can see might be right here. So let's try it. You know what? This one's close too, and it might trick you, but it is not a perfect right angle. It is not. Do you want to check the other ones just to be sure? Nope. And no. Okay. I stand by it. Did we do P already? I guess not. P doesn't have any right angles, does it? There are no perpendicular lines. No lines like this. Or like this, right? So no. How about T? Oh, I think I'm seeing some. They're not up here, but they are. There's one here at the bottom. And there's one here on the other side. So T fits that attribute. And how about N? Yes, N fits that also. One right angle, two right angles, three right angles, and four. And there's your N. Okay, out of all of those, go ahead and sketch whichever one you'd like. I'm going to do T, I think. I think that's kind of a fun shape. Kind of look like a barn or something. I didn't quite angle this one in enough. There we go. Okay. Now, our last qualification that we're looking for is at least one set of parallel sides. Remember that we talked about parallel like this. These are parallel lines. These are perpendicular. What's unique about parallel lines is that they will never touch. If they go on and on forever, they will never touch. Parallel. Okay. So right away, we know that none of these lines in Q are parallel. No sets. Goodbye. How about S? Yes, two sets. S qualifies. How about T? I just drew it, and it does actually has two sets. These two right here, and the ones on the top and the bottom. T. How about N? Again, N has two sets of parallel lines, top and bottom, side and side. So any rectangle is going to have two sets, right? Ooh, how about P? What do you think? I mean, if you get one set, like on this side, right? And these go on forever, are they going to be parallel? Let me get something to go on each side of this to see. This, nice straight edge on this side. Yeah, those are parallel, aren't they? Those would go on forever and never touch. Okay. P fits. P. How about V? No, that's not parallel to that. That's not parallel. If these were to go on, actually this way, they would touch. If these two were to go on, they would touch. No. R? What do you think? Yeah, this bottom set is parallel, isn't it? Or the top and the bottom, rather, are parallel. So R fits our qualification. How about this one in X? The top and the bottom are parallel, aren't they? Whoa. And what about M? It has all kinds of parallel lines. This side, this set, this set, this set, right? All parallel to each other. These two, their opposites are parallel. Excellent. How about W? No, sorry, they're all touching. It's not going to work. Are any of these sides parallel? That goes up this way, that goes out that way. I even think even these two aren't parallel. Those would touch. Yeah. O does not have any parallels. And the last one is U, where I guess the top and the bottom are certainly parallel. I'm wondering, do you think these two are parallel also? And these two? I kind of think they are. But all it takes is one side to... Peter went to sleep. It's 15 minutes, or the 20-minute mark. It falls asleep. It only takes one set of parallel sides to qualify. So you made the list. Okay, now choose any of those that have parallels to sketch out. Let me see. I think I'll do M. You choose whichever one you would like. I don't know if this is the best way to do this. I guess we'll see now. I'm doing it by parallel sides. Parallel. That doesn't look too bad. Looks like a great stop sign, right? All right. Shall we flip? Let's flip-a-roo. And let's read. There we go. Let's read number 2 together. Compare polygon M and polygon X. What is the same? What is different? I'm sorry, guys. It's so blurry today. I'm not sure why, but hopefully you can read it on yours and it's not so bad. Okay, so here's M and here's X. Let's just make a little table. Same on one side and different on the other side. Right off the bat, we know it's the same. For one thing, they're both polygons, right? So I'm going to write polygons. What else is the same? What else is the same? If we look at our chart over here, is there any category, any attributes where M and X are together? Do you see them? Yeah, I see down here. So that's one thing that where they're the same, right? They have at least one set of parallel sides. So I'm going to write that here. One set. Maybe I'll write at least one set of parallel sides. What about the number of sides? That's one thing that I'm thinking that might be different about them. Let's see. 1, 2, 3, 4, 5, 6. This has 8. I'm going to start at the top again so I know where I started, so I know where to end. 1, 2, 3, 4, 5, 6, 7, 8. Oh, they both have 8 sides. I was not expecting that. I'm going to put a little bullet there so I can remember. I don't know, I'm writing that 8 sides. What's some things that are different? If we flip back over, we can see if any of these have M only or X only. So this one, has M has all sides equal, and clearly X does not have all sides equal. And down here, X has at least one right angle, where M does not. So those are some differences. I'm going to say M, all sides equal. And X, one right angle. At this time, what else what else do you notice that is similar or different? Is there anything else we can add to the list using its attributes? I think that's pretty complete at this time. Okay, let's go on to number 3. Will you please read it with me? Jenny says polygon N Polygon R and polygon S are all regular quadrilaterals. Is she correct? Why or why not? Okay, well, let's get R, N, and S out. What is a regular quadrilateral anyway? Great question. I'm going to read to you the definition so that you will know. Regular quadrilateral. We have not spoken about this before. You ready? A regular polygon is a shape whose sides are all the same length and whose interior angles are all the same measure. So a regular quadrilateral is a shape that has 4 equal sides with all the interior angles equal. Okay. So remember how yesterday I was talking about we were talking about only quadrilaterals. If a shape has 4 sides, it also has 4 angles. This one has 4 right angles. So this one qualifies in the angle department because all 4 angles are the same. Are all 4 angles the same in this one? They are not. This one is acute and this one is obtuse. We're going to get into that. If you're like, Mrs. Brady, these words, I don't know what you're talking about. Don't worry about that. This one does not qualify. It does not have 4 equal angles. This one has 4 equal angles. This one has 4 equal angles. Angles. We got a right angle here, a right angle here, right angle here, right angle here. Same for N. However, what was the other qualifying thing to make it a regular quadrilateral? I'm going to read it again. A regular polygon is a shape whose sides are all the same length. And that is only true of one of these shapes. It's only true of S, right? So when it's asking, is she correct? We can say she is not. Oops. Sorry, Jenny. So let's write. No, Jenny is not correct. We can say a regular quadrilateral must have 4 equal side lengths, let's say. 4 equal side lengths and 4 equal interior angles. I'm going to write polygon N, and polygon R do not fit these qualifications. There we go. All right, let's read number 4 together. It says, I have 6 equal sides and 6 equal angles. I have 3 sets of parallel sides. I have no right angles. So then A says, write the letter, and the name of the polygon described above. Well. So we can count some out, right? So the only ones that have all sides equal are these ones. So let's just get those ones out. Here's M, S, P, where? Oh, here's P. P, W, U, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so I have my 5. Now let's see what other qualifications or what other attributes it has so we can eliminate some of these. I have 6 equal sides. How many sides does this have? Not 6. Bye S. How many sides does this have? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Nope. Oh, you? Are you the winner? Let's see. 1, 2, 3, 4, 5, 6 sides. This has way more sides. This only has 3. Counting those out. U is the one we want. You're the shape we've been looking for. Maybe, because it says I have 3 sets of parallel lines. Is that right? I have no right angles. Well, we know it doesn't have any right angles, so it qualifies there. Does it have 3 sets of parallel lines? I believe it does. We know that these two are parallel. We can tell just by looking. Now, if we turn it sidewards, oh, yeah, those are certainly parallel. And if we turn it sidewards again, those are certainly parallel. We did it. We found it. U. It's been you all along. All right. Write the letter and the name of the polygon described. Letter, or I guess we can say polygon. U is the, what do we call this? What do we call a 6-sided shape? Do you know? You have your octagons, you have your pentagons, you have your rhombus, quadrilateral, parallelogram. What do you think this is? Yes, it's hexagon. So I'm saying the polygon U is the hexagon. Boop. Will you read B with me, please? Estimate to draw the same type of polygon as is in part A, but with no equal sides. So what it's asking is for us to draw a 6-sided figure, but that doesn't have equal sides. Can we do that? Sure, I'm up for the challenge. Go for it. 1, make this one longer, 2, 3, 4, 5, 6. What does yours look like? Will you email me if you can? Will you take a picture of yours and send me what yours looks like? I'd love to know. And if you don't know my email address, it's albrady@d49.org. Don't forget that little L, because then I won't be myself. I mean, I will be myself, but it'll be A Brady, which is someone that is not me. So don't put A Brady, put A-L Brady. Please, please, please. Okay, great job today. I know this was another kind of a long lesson, but you stuck in there and you saw it to the end, and I appreciate you. Have a great day. Catch you on the flip.